Section 6.2 is on the law of cosines. The law of cosines is derived using the Pythagorean theorem, which is why it has all these squares in it. Okay, it's used to find the missing sides or angles of a non-right triangle, although it can be used for a right triangle, when the law of sines doesn't work. And it's c squared equals a squared plus b squared minus 2ab cosine of c, where the side A is opposite the angle A, etc. If you rearrange this, it looks like this. The second form is useful sometimes when you're trying to solve for an angle. Okay, before we do that, I'm going to show you a notation you may have not seen before. Sometimes they will call an angle in terms of degrees and minutes. I think it has to do with something with sailing, but I don't really know. Okay, but it doesn't matter because your calculator knows, and if your calculator doesn't know, you can convert it on your own. Okay, so the way this is actually written with symbols is 75 degrees, 10 minutes, and the minutes is an apostrophe. Okay, if you are using a scientific calculator, you would hit 75 degrees, and you probably have a button on your calculator that has a degrees. Looks like this. It has a degrees, an apostrophe, and a quotation mark, but really it's degrees, minutes, seconds. So you type 75 degrees, 10 apostrophe, and you put it in the calculator, and it spits you out a decimal, and then you just use the decimal the whole time. The decimal it should give you is 75.1666 forever. If you're using a graphing calculator, you can find the degrees, the minutes, under the angle menu, which on my calculator is above the apps button. So I do second angle, I hit the degrees button, I type 10, and then I do second angle, I slide to the minutes button, and I also get 75.166. I don't know about the Google calculator. Okay, if your calculator doesn't know how to do this, or that's just too much work for you, that's fine. The way you would do this without your calculator knowing it, 10 minutes is when you divide it, a degree into 60. Each degree has 60 minutes, which is kind of easy to remember because you think 60 minutes in an hour. So it's really just saying 75 plus 10 over 60, which also gives you 75.166, blah, 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 blah. Okay, once you convert it, you don't need to worry about the degree button anymore. Okay, however you want to do it is fine. Okay, so for example 1, I'm going to sketch a picture. You don't need to sketch a picture, but I'm going to do it so that visual people can see it and to show you when the law of cosines is useful. I'm drawing a random triangle, ABC. When it says solve the triangle, it wants me to find all the angles and sides. Okay, so A is 75 degrees, 10 minutes, or I could write the decimal. Side B is 12. Side C is 10. I don't know what side A is. Okay, so if I look at this, if I wanted to try to use the law of sines here, well, let's first see. I couldn't find angle B or C. Well, could I find angle B? Let's see. Angle C is over 10, but I don't know angle B, so I couldn't put it over 12. If I wanted to find side A over sine 75, blah, 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 equals, I don't know angle B or C. So law of sines doesn't work here. Because law of sines does not work here, that is the only reason I would use law of cosines. Okay, and I normally look for this little SAS configuration. I know a side, the included angle, and then another side. So I'm actually going to find side A first, and I'm going to use the first configuration of the law of cosines. The A, B, and C can be switched around, but since I'm solving for A, this is going to be the cosine of A. And then these two are going to be the other two sides, the adjacent sides to the angle. So this is going to be A squared equals 10 squared plus 12 squared minus 2 times the adjacent sides times the cosine of the angle opposite A, which is 75 degrees, 10 minutes. Okay, put that entire expression in your calculator. Okay, if I put the entire thing in my calculator, I get A squared is about 182.56. To cancel the square root, I square root. And because we're talking about the side, it's going to be positive. So about 13.51. They didn't give me units, so I'll just leave it like that. Okay, because it wants me to solve it, the triangle, I need to find all the sides, which I did, but now I need to know all the angles. So let me try to find an angle next. Let's see, to find angle B, I think I'm just going to do B next. Okay, because I have side A, I could use law of cosines and solve for the angle, but to be honest, I just prefer law of sines, so I'm going to use law of sines to get angle B. So I'm going to say sine of B over 12 equals the sine of 75 degrees 10 minutes, or the decimal approximation, over, what did I just get for A? 13.51. Okay, let me put this in my calculator. The sine of B is about 0.8586. So if I do inverse sine on that, I get about 59.16 degrees. That's not a degree sign. Okay, degrees for my answer B. I'm going to consider B prime in a second, but let me find C real quick. C, you can use your calculator once you have two angles. So if I do 59.16 plus 75.16, 17, subtract 180, I get about 45.67 degrees. Okay, I'm going to go back and look at B prime and see if that makes sense or not. Okay, remember to find B prime, because I've used inverse sine. I do pi minus x, or 180 minus x. So if I do 180 minus 59.16, I get approximately 120.84 degrees. Okay, before I continue, I'm just going to make sure that makes sense. Let's see, I already know that one of the angles is 75 point something. 75 plus 120 is already 195, which is way too high for a triangle. So there is no alternate answer for this. These are the only measurements that would work for this triangle. Okay, example 2 is the second scenario when you often use the law of cosines, although you are welcome to use the law of cosines more often than that. Okay, that would be when you're trying to find all the angles and you are given none of the angles. Because in order to use law of sines, I need to have at least one angle given to me. Okay, just for the sake of naming it, I think I'm just going to call this ABC. And that's just so when I solve, you'll know which angle I'm trying to solve for. Okay, now when you're finding all the angles, in theory, you could start with any angle you want. It's less work if you find the largest angle first. I will show you why after we do this, but strategically, it makes more sense to find the largest angle first. Okay, so how do I know which one's largest? The largest angle is opposite the largest side. So since 13 is the longest side, according to my naming, angle B should be the largest angle. Okay, since I'm trying to find the angle, I'm going to use the second format of the law of cosines. Although it doesn't matter, you could just have to rearrange it. Okay, and again, you just have to make sure that if I'm finding the angle B, then that special side is the B. So let's see, angle B, the two adjacent sides are 7 squared plus 9 squared minus 13 squared over 2 times 7 times 9. Okay, I'm going to put that entire right side into the calculator. The cosine of B is about negative 0.3095. If I do inverse cosine, I get about 108.03 degrees. Okay, I'm going to pause for a second and tell you why there's no B prime here. Okay, since I used inverse cosine, there is a second answer. We could use it. Remember, if we do it, it's either going to be the negative of this answer would be negative 108 degrees, which doesn't make sense in a triangle. Or I could do 2 pi minus this angle, or 360 minus this, which would be 200 something, but which is also too large. So the one nice thing about law of cosines is it's not going to give you the alternate. Okay, now let me look. I have one of the angles, so I can use law of sines now, which I find more convenient, but you might not. Okay, what should I'm just going to find angle A next, and I'm going to use law of sines. So now I can do sine of A over 9 equals the sine of 108.03 degrees over 13. Okay, a value times 9. I get about 0.658-ish, which means A is approximately 41.17 degrees. Okay, now if I found the largest angle first, I don't need to consider A prime. That's the main advantage here. Okay, and then to find angle, what am I missing? C? You don't need to show work, but do 41.17 plus 108.803, subtract from 180, and I get 30.8 degrees for my final angle. Okay, this is when we found the largest angle first. I'm going to not find the largest angle first, and I'll show you what will happen. It's not that it's wrong, it's that it's more work. Okay, so I'm going to do this problem again, but I'm just going to find a different angle first. I think I'm going to find angle A first. Okay, I know, hopefully you're still looking at your picture. So if I want to find angle A, I could do 7 squared plus 13 squared of the adjacent sides to angle A. Okay, let me plug this in. If I inverse cosine, I get 41.17 degrees. And this seems correct because this is exactly what I got the first time. Okay, now I'm going to try to find angle B using law of sines. And then side A is 9. Okay, if I do sine B and then I do inverse sine, I get 71.97 degrees, which is a little odd because that's not what I got the other time I did it. Okay, what is C? I'm going to do 71.97 plus 41.17, subtract 180. I get 66.86 degrees, which is interesting because it doesn't match. Okay, now I'm also going to look at B prime. B prime would be 180 minus 71.97, which is 108.03 degrees, which if I add to 41 degrees is okay. So this seems like it might be valid. C prime, 108 plus 41, subtract 180, I get about 30.8 degrees. Okay, so it seems like I got extra answers here. Okay, it's not that my work is wrong, it's that I need to go back and figure out which one's actually correct. Okay, unfortunately I don't have the picture on this side. Okay, but the way you want to check if your work is correct is you want to make sure that the largest angle is opposite the largest side, the medium's angles across from the media side, and so on. Okay, so let's start with the first scenario here. Angle, if I have this for A, this for B, and this for C, B is the largest angle. The largest side is 13 across from it, so that seems reasonable to me. For C, I got 66.86. This is the medium angle, so it should be opposite the medium side. But angle C is actually across from the smallest side. Because it fails the angle side, what's it called, an identity thingy, it doesn't work because it's not consistent with the sizes of the sides. Okay, let me check and see if my alternate answer worked. Okay, so for now I have A is 41, B prime 108, C prime 30.8. B should be opposite the largest side, which it is. C prime is the smallest angle, and it should be opposite the smallest side, which means this medium angle is across from the medium side, which is how I know that this answer is valid. And of course, if I had found the largest angle first, I wouldn't have had to go through that whole process.